Hi, math lovers. Welcome to notes number 47. We're going to talk about transformations today of functions. Hopefully you got an opportunity to play around with Desmos. And now we're going to formalize what we did and make some rules and then go ahead and use them to work with our problems in our problem set. Okay, so first off, we talked about a plus or minus on the outside. This is C. Imagine C is some constant and f of x is your function, and we're going to make some kind of transformation. So plus or minus C, that's an outside number. This is an outside number, all right, an outside number, and that's going to move it up or down, okay? Now, just like an outside number would say, a plus 3 would move your function up 3, a minus 3 would move your function down. So a plus is going to move your function up, and a minus is going to move your function down. Inside the parentheses, that's called an inside number. Well, I call it an inside number. And that's going to move your function from the left, either left, or it's going to move it right. Now, if I'm thinking about it, if I'm going to have a plus 3 to get the same result, I need to put it in x that's 3 less. So these are backwards. All right, so backwards then you're thinking on a number line. If I'm going to do a positive number, right, I need my number to be 3 less, so I move to the left. So a positive is going to move it to the left, and then a minus sign is going to move it to the right, okay? Now, an outside is the function. So I'm going to do the whole function, and then I'm going to reflect the whole thing over the axis. So then outside here, this is going to be a reflection. Okay, we're going to reflect this over the x-axis. All right, because I'm going to take all of my numbers, I'm going to calculate my values, and then if something is in, say, quadrant 2, and then I reflect it, it's going to end up reflecting over the x into quadrant 3. In the inside of the parentheses, this is a little bit different. So say it's a positive 3 to start with. Now I'm plugging in, instead of positive 3 for x, I'm putting in a negative. So this is going to also be a reflection, but this time it's going to reflect over the y-axis. Okay, I should say over. And then transformations. We're not going to talk about so many transformations today. We'll do more of those tomorrow. But transformations are going to be multiplication. So what I'm going to do is I'm going to take the number and I'm going to multiply it. These are called shrinks or stretches. So transformation, these are going to be, your book calls them a stretch or a shrink. I like to think about the function getting wider or narrower, but that's what they use. So inside here, inside the function, imagine I'm multiplying it by some constant before I go ahead and figure out the function. And this is going to be a horizontal shrink or stretch. And on the outside, this is going to be a vertical, okay, shrink or stretch. Like I said, we'll talk more about those tomorrow. I have some good examples. All right. So I'm going to pull an example from your textbook. I'm looking at number 8 on page 224. I've got 3 different functions, and I'm going to substitute in a negative 3 for each of them, and I'm going to substitute a positive 3 in for each of them. Okay. So let's start here talking about these 2 first. I've got the square root of x. Now think about the parent function for the square root of x. Remember, it starts at the origin and then it kind of shifts up. So if I have my graph, I'll do that in pencil for you. So my parent function is going to look like this. I'll do that in pencil. Hope that comes up on the video. So my parent function is right here. I've got it in there, and I'm going to use an outside minus 3, so it's going to go down 3. So down to 3, and my function is going to be right there. Inside, over here, I have a plus 3, so I'm going to move that function up 3, and there it is right there. Okay. Similarly, I have functions that are on numbers that are on the inside. My constant here is 3. So go back to my parent function. Okay. I guess I could draw all of those. All right, so here's my parent function. Okay. So there's the parent function in pencil. Now I have an inside number. So an inside number is going to go to the left or it's going to move to the right. A plus 3 is going to mean that my number has to be 3 less. So my starting point is going to be over 3. So my function is going to go just like that. And inside minus 3 is going to take that function to the right 3. So I'm going to go over 3. Say this is 3 here. And it's going to go to the right. Now, we've got two things going on, inside numbers and outside numbers there. So an inside minus 3 and an outside minus 3. The outside minus 3 is going to move it down 3. The inside minus 3 is going to go ahead and it's going to move it to the right 3. So I'm moving over 1, 2, 3, and then down 3. So it's really putting these two motions together. Same thing over here, except this time I've got a positive 3. So I'm going to move it to the right 3 and up 3. So there's my function there. Okay? Good problems? All right, let's ready to try some more. I heard you. You said yes. Okay. So let's try number 17 here together. Make sure I'm focused. Okay. Number 17 is an absolute value function, and I'm going to go ahead and add 5 to it. So before we even start on all of these problems, I'm going to draw for myself the parent function in pencil. So you have a point of reference. Now, friends, these are just sketches, okay? We're talking about transformations in terms of our parent function, and I'm just sketching them. You guys, when you get to the more high-powered math and you need have application questions in your physics and your science classes, you're going to want to be really precise, and you'll use technology to make sure that you have exact values. But for us, we're just talking about what the transformation is going to do here. So here I have an outside plus 5. I go back to my rules. Outside plus 5 is going to shift it up and down. So I'm going to take this origin point here and I'm going to move it up to 5. And there is my parent function, or my new graph. The outside, I have an outside minus 3. I'm sorry, not minus 3. I have an outside minus, outside the absolute value, and an inside plus 3. So my plus 3 on the inside is going to move it to the left 3. And then the minus is going to reflect it down. So all my points that I had were positive are now going to become negative. In this third one, I have an inside minus 2. All right, so that's going to move it to the right 2. So here I am at 2. And I have minus 4. So that minus 4 is going to take the function and shift the whole thing down 4. So I moved it over 2 to the right because of the minus 2. And I'm moving it down 4 over here. So I'm going to start my graph this way, and I'm going to draw that same beautiful V graph. All right, I've got a lot going on in this last one. This is a fun one. Look at all I have. I've got an outside minus 1, an inside minus 6, and a negative out in front to reflect the whole thing. All right, I'm going to start on the inside. And inside minus 6 is going to shift the whole thing over 6. So here I am at 6. I'm going to shift it down 1 because of the outside minus 1. So here I am. And then got a negative on the outside, which is going to reflect the whole thing down. So that's a lot of fun. Okay. Number 31, they want us to graph this. G of x is equal to 2 minus the quantity x plus 5 squared. All right. Now, a couple ways you could go. You want to graph that. Maybe you want to make a t-chart. Think back to your fun days in Algebra 1 and make a t-chart. You could go ahead and do that. You could spend all day doing that, but I'm going to think about it as a transformation, and that's what our point is today. So let's reorder this so it's in that common form that we're looking at. All right. So let's look at all the different parts that we have here. I have a plus 2. That's going to shift the whole thing up 2. I have a plus 5 on the inside. That's going to move it to the left 5. And a negative on the outside, that's going to make the whole parabola open down. All right, it's going to change the orientation of my graph. So let's see. My regular parabola, my beautiful parabola, my parent function, which I'm going to just sketch right here in pencil. Okay. I'm going to start here with my left 5. So I move to the left 5, and I'm going to move it up 2. There it is right there. That's my vertex. And then my negative sign is going to flip the whole thing down. Okay. The last thing Ron asks us to do in this problem set, he says, think about the parent function. Your parent function is f of x is equal to x squared. So how would I rewrite g of x in terms of f of x? I would say g of x is equal to, right? G of x is equal to, take that parent function. I had an inside an inside plus 5, so x plus 5 on the inside of my parentheses. I had an outside plus 2, and I had a negative out front, so I'm going to just put that negative right out front, that f of x, all right? So don't be afraid of the notation. The notation is just going to tell you exactly how to write the new function. And go back to your rules. When you're not sure how to graph it, go back to your rules, pull out your technology, pull out your handy dandy TI-84, or use Desmos to graph it to make sure you're right. Have fun with your problem set.